Okay, this week you will be working some homework problems from section 9.5, and a lot of them are word problems. So if you want a little bit of extra help, I want to show you that your ebook does have some ways for you to get some extra practice. So what you want to do is click here on chapter content in the My Math Lab, and then find your chapter 9, and we're going to go to section 9.5. And I'm going to look over here to view the multimedia e-text. So then the ebook is going to come up. And I've gone to the chapter contents and found section 9.5, which is quadratic functions. Actually, I'm going to go now to the homework at the end of this section. So let's see here. Let's see. And you can see through here, by the way, as you go through the actual ebook, you will see some icons here in the ebook that give you some extra help. And I wasn't sure if you were aware that these are here. For example, here example 3, where you have to find the x vertex and intercepts. You have a try it example 3, which looks like this. And see, it asks you to find the vertex, y-intercept, and x-intercepts of the following function. But there's the button help me solve this. And so you can literally go through it. It's going to help you do this problem. So right as part of your book. Okay, and so I wanted to show you that. I'm going to do a word problem just to help you, but I'm going to close out of here. I just want you to see this. You also have here an animation. Let's see what that brings up.
For example, we will graph the quadratic function f of x equals negative x squared plus 4x plus 1. Then we will use the graph to identify the function's domain and range. First, we determine how the parabola opens. Notice that the coefficient of x squared is negative 1. Thus, a is less than 0. This negative value tells us that the parabola opens downward.
Okay, so this is important because one of the questions that I've gotten in the past is how do we figure out if a parabola has a maximum or a minimum point? And this animation has already talked about how the fact that the coefficient of the x squared term, which you can see in this example, is negative 1. See how you have a negative x squared plus 4x plus 1? That's the, we call that the a coordinate. It's the a coefficient. And so a equals negative 1. And anytime that the coefficient here of the x squared term is negative, you're going to have a parabola that opens downward. And what that means is that that parabola will have a maximum. It'll have a highest point because of the fact that the parabola will open downward. Okay, so let's continue here.
The next step is to find the vertex. We know that the x-coordinate of the vertex is negative b over 2a. Using the values of a, b, and c from the function, we find that the x-coordinate of the vertex is x equals 2. Recall that the quadratic formula tells us that x equals...
All right, so what's happening here is the x-intercepts are the place where, or the 2 points where the parabola will intersect the y-axis. And so the way that you find that is that you set y to 0 and then solve for x. And so we rewrite our original quadratic function but with a 0, and then we use the quadratic formula to solve for x. So that's what he's doing at this point. Okay, let's continue.
Of b squared minus 4ac divided by 2a. We substitute the values of a, b, and c from the function in this equation and solve for x. Thus, the x-intercepts are approximately negative 0.25 and 4.25. Next, we find the y-intercept by computing f of 0. Substituting 0 for x in the function gives us a y-intercept of 1. Thus, the parabola passes through 0, 1. Now we can use the points we found, the vertex, x-intercepts, and y-intercept, to graph the function. Because the parabola opens downward, we use a vertex at 2, 5, x-intercepts at negative 0.25 and 4.25, and a y-intercept at 1, to produce the graph shown.
Okay, so I want you to notice that this example has a parabola that opens downward, so that vertex gives you the maximum point, the point that is tallest. Okay, so when they're asking for a maximum, whether a parabola has a maximum or a minimum, what they're really asking is, does the parabola open upward or downward? This one, because, and again, I'm going to tell you that it's the coefficient of x squared that determines that. If the coefficient of x squared, the number in front of the x squared, is a positive number, then your parabola will open upward and you will have a minimum point, and that will be the vertex. But if, as in this equation that we have here in this example, your coefficient is a negative number, then you will have a parabola that opens downward, and that vertex will be your tallest point. So we say that that vertex, that the maximum of the function will actually occur at that vertex. Okay, I hope that's making sense. But let's move on and see what we got going here.
We can use the graph of the parabola to determine the domain and range of f of x equals negative x squared plus 4x plus 1. Notice that the inputs on the x-axis include all real numbers. Thus, the domain of f is x such that x is a real number, or negative infinity to infinity. The outputs on the y-axis fall at or below the y-coordinate of the vertex, which is 5. Thus, the range of f is y such that y is less than or equal to 5, or negative infinity to 5.
Okay, so that was an example on how to find domain and range by looking at the graph. And let's continue.
Therefore, the graph of the quadratic function, f of x equals negative x squared plus 4x plus 1, is the parabola shown, with a domain of negative infinity to infinity and a range of negative infinity to 5.
Okay, so that was excellent. I just wanted you to be aware that right within the ebook, you've got some buttons that can help you learn the material, especially if you're struggling this week with section 9.5 or any section, right? So we're just looking at 9.5 here. Okay, now let's go look at a word problem. Okay, now I'm on page 587, which is the homework problems, or the problems at the back of the section right in your ebook. The reason that I wanted to show you this is because some of the problems here also have animations to help you solve them. So that if you're in my math lab homework, you've got a similar word problem to one that's in the book, and the book has some sort of animation or multimedia to help you, then you may want to try this here with the book. So let's read this one. It says, it's number 37. Susan throws a softball upward into the air at a speed of 32 feet per second from a 40-foot platform. The height of the ball after t seconds is given by the function d of t equals negative 16t squared plus 32t plus 40. What is the maximum height of the softball, and how many seconds does it take to reach the ground after first being thrown upward? Round your answer to the nearest tenth. Okay, so this is awesome. So what we're going to do here is I'm going to actually cut and paste this to another document so that I can write and show you how to do this problem. Okay, before I show you the solution to number 37 here, I want you to see again that you've got this help. So when I click here, it says here that you have an exercise set here for exercise 37. Click that link. And here again is a similar problem, just different numbers. And you will have a chance to use the Help Me Solve This to help you solve the problem and also view an example. So you've got the tools right here within the book. Okay, but I'm going to solve the problem. But I want you to look to the book, to the ebook, to find similar problems when you get stuck with the homework. Okay, all right, so here's our problem with Susan. And first of all, that first sentence, really, that material, we don't need to really use this material right here, because what we're interested in is that you are given a height function for the ball. And so what's happening is that the path of the ball is given by this function, which hopefully by now, based on your work, you know that this is a parabola, right? Because it's got the t squared. It's a quadratic equation. It's a quadratic function, and it's a parabola. And here's the thing: the a, right? The coefficient of t squared is negative, so you should know that the parabola opens downward, and the height of the ball is given by this function, which means that when you substitute in a value for t, and t is how long has the ball been in the air, right? Because t is the number of seconds after Susan throws the ball, okay? So when you substitute in values for t into this quadratic equation and you do the math, the answer that you get back out is the height of the ball at that particular time. So if you put in t equals 1 and substitute in here, then you would be finding the height of the ball at 1 second. If you put in t equals 2, you'd be finding the height of the ball at 2 seconds, and so on, okay? Well, we want to find the maximum height of the softball. And because we know this is the function with the path of the softball, and we recognize it as a parabola, we know that the maximum height of the softball is going to occur at the vertex. So really and truly, this sentence here, what is the maximum height of the softball? It's just asking us to find the vertex of that function. Okay, so here's the function again. Okay, and again, A is negative 16, B is 32, and C is 40. Okay, so now we're going to use the fact that the x-coordinate of the vertex is at the opposite of B over 2A, right? So we read that in the book. And so we're going to write the opposite of 32, because that's our B, over 2 times A, and A is negative 16. So now we have negative 32 over negative 32, and negative 32 divided by a negative 32, as you know, is positive 1. So you have just found the x-coordinate of the vertex of the highest point of the parabola. And so remember that x, and actually I guess I apologize to you, I should be using t here because our independent variable is t, not x, so this really should be t. So we have just found that the vertex of this parabola happens at t equals 1. So when the ball has been, when Susan throws the ball, 1 second after she's thrown it, it reaches its highest height. Okay, so we need to find that height, because as the question is, find the maximum height. So we're going to substitute t equals 1 into the original equation. So negative 16 times 1 squared plus 32 times 1 plus 40 is what we're trying to, this will be the height. Okay, and so now you do your order of operations. So we're going to square 1, which is just 1, as you know, times negative 16 is negative 16. 1 times 32 is 32. We do multiplication here. And now we can add. And over here on the right, I have a 72. And I have a negative 16. And so it looks like 56. So it looks like 56 feet is the maximum height of the ball, right? Okay, now it says, so that's the first question. What is the maximum height of the softball? The second question is, how many seconds does it take to reach the ground after first being thrown upward? And so, and you know what's happening is this, because we talked about this being a parabola, right? And now you've just found that at t equals 1, we've got our highest point, and it's at 156, right? And so this guy, is being thrown and then coming back down again, and then finally it's hitting the ground, right? Okay, so that's what's happening. This is the highest point, and then the ball starts to drop, and you're looking for what time does it hit the ground? Like, how long is it flying before it hits the ground over here, right? So basically what you have to remember here is that we don't know t, that's what we're looking for, t, but we do know h. because h is like our y-coordinate, right? H is the height. And if this is the ground, then how far off the ground is the ball? Well, the ball is 0 off the ground, right? It's on the ground, so the height is 0. So to answer the second question here, we're going to write 0 equals negative 16t squared plus 32t plus 40. We're going to solve this quadratic equation, and we're going to use the quadratic formula to solve it. All right? Now here's the thing. Just to make my numbers smaller, I can see that all of these coefficients here, all these numbers are divisible by, looks like 8. Right? So we're going to go through, I'm going to go through and divide both sides of this equation by 8. And so then I'm going to get 0 equals negative 2t squared, right, divided by 8 plus 4t plus 5. So that's way nicer now to use this, right? So then we're going to go t equals the opposite of b, negative 4, plus or minus the square root of b squared, which is 16, 4 squared, minus 4 times a times c. A is negative 2, c is 5, so when you multiply those two, you get negative 10, right? All over 2 times a, and a is negative 2. Okay, so now what I'm going to do is I'm just going to put, just simplify that and get some decimals here. Because it said round your answer to the nearest tenth. That's a hint that they want a decimal, right? Okay, so what I did was that I went to my graphing calculator, and so I added here the 16 plus 40 and got 56, and square root of 56, and then I came over here to my graphing calculator, and I first put negative 4 plus square root of 56, found that decimal, and then divided by the negative 4, just like it says here. I did it like in 2 steps. This time I got a negative 0.87, and t is time, so the ball was at the ground before it was thrown. Yeah, possibly, but that's not what we're looking for, right? So we're gonna not use that answer, and we're gonna come to this one, which is negative, and this time I use parentheses to do it all in one step. Negative 4 minus square root of 56 divided by negative 4. And now I got 2.87. And since they want the answer in one decimal place, then we round up to 2.9 seconds. So the answer to part 2, t equals 2.9 seconds. So I hope this helps, but mostly I wanted you to see that the book does have some other features to help you this week as you do section 9.5.